Assalamualaikum and good day. My name is Nur Hidayah binti Muhammad Nizam, and today I will be presenting my poster entitled of Development and Instrumental Evaluation of Agar Alginate Coating for Sustainable Paper Packaging. This study is motivated by the growing environmental concern related to plastic-based packaging. The conventional paper coatings are mostly derived from petroleum-derived, non-biodegradable, and contribute to environmental pollution. Therefore, the paper packaging industry is increasingly focusing on bio-based and sustainable coating material. In these works, agar and alginate, which are natural polysaccharides obtained from marine sources, were selected as alternative coating material due to their biodegradability and good film-forming properties. The scenario of this study is based on a paper packaging manufacturer that aims to develop a biopolymer coating to improve paper surface properties while maintaining sustainability. However, this performance of agar and alginate coating depends not only on the organic polymer system but also on the presence of inorganic cross-linking agent, that particularly calcium ions, which enhance the water resistance. Therefore, the objectives of these studies are to qualitative and quantitative analyze organic agar-alginate polymers and to qualitative and quantitative determine inorganic calcium ions in the coating system using UV visible spectrophotometry. So why use UV visible spectrophotometry? UV visible spectrophotometry was selected because it is a simple, rapid, and reliable analytical technique that commonly used in a pulp and paper analysis. Organic polysaccharides that absorb UV light in the range of 200 to 240 nanometers due to their functional groups, while inorganic calcium ion can be detected and quantified using colorimetric composition reagents. This makes UV with spectrophotometry suitable for both qualitative identification and quantitative determination of coating components. First, for qualitative organics analysis, the extracted coating solution was scanned from 190 to 350 nanometers. Agar shows an absorption peaks around 210 to 220 nanometers, while alginate shows absorption near 230 nanometers. When both polymers were blended, the UV spectrum showed peaks, broadenings, and increased the absorbance that indicates interactions and compatibility between agar and alginates. For qualitative inorganic analysis, the extract sample was react with the reagent and scanned from 500 to 720 nanometers. A distinct absorbance peak at approximately 650 nanometers was observed, and confirming the presence of calcium ions, which actually which acts as cross-linking agents in their coating. Next, for quantitative organics analysis, agar-alginate standard solution was prepared and measured at 220 nanometers. A calibration curve was constructed based on the Beers-Lambert's law, and using this calibration curve, the concentration of agar-alginates in the coatings extract was determined. The higher polymer concentration is associated with improved film formation and coating uniformity. For the quantitative inorganic analysis, calcium standard solution were react with the reagents and measure at 950 nanometers. The calibration curve allow accurate determination of calcium ion concentration in the coatings, and the result shows that calcium concentration plays an important role in improving water resistance, although the excessive calcium may reduce the coating flexibility. So in conclusion, the study demonstrates that UV visible spectrophotometry is an effective instrument that analyzes the technique for evaluate agar alginate-based coating. This method successfully provided the qualitative confirmation of polymer interaction and calcium cross-link and quantitative determination of both organic polymer and inorganic concentration. This analytical approach supports the development of sustainable biodegradable coatings for paper packaging application and align with current industry trends towards the environmental friendly materials. Thank you for attention.